Hello guys, welcome back. Today I'm going to demonstrate on data parallelism. Before that, I'll talk a little bit on sequential programming and parallel programming. To give you an idea of what is sequential programming and parallel programming, let me give you an analogy of cooking. Let's say in a restaurant, 10 customers came into the restaurant and ordered the same dishes at the same time. I know this is not so realistic, but this is just to explain the idea of sequential and parallel programming. Back to the restaurant. In that restaurant, there is only one junior cook, and to prepare and cook for that 10 customers, the junior cook will cook for one customer, one dish at a time. To cook for 10 customers, the junior cook will need 2 hours. This is sequential programming. So the owner of the restaurant decided to hire one more junior cook, and by doing so, the waiting time reduced to 1 hour. That is parallel programming. In sequential programming, one thing happens at a time. Sequential programming is what most people learn first and how most programs are written. Probably every program you've written is sequential. Execution starts at the beginning of main and proceeds one assignment operation at a time. Many computers have multiple CPU cores that enable multiple threads to be executed simultaneously. To take advantage of the hardware, you can parallelize your code to distribute work across multiple processors. In the past, parallelization required low-level manipulation of threads and locks. .NET Framework enhanced support for parallel programming by providing a runtime, class library types, and diagnostic tools. These features, which were introduced with the .NET Framework for simplified parallel development. You can write efficient, fine-grained, and scalable parallel code in a nature idiom without having to work directly with threads or the thread pool. Task Parallel Library (TPL). TPL is a set of public types and APIs in the system.trading and system.trading.task namespaces. The purpose of the TPL is to make developers more productive by simplifying the process of adding parallelism and concurrency to applications. The TPL scales the degree of concurrency dynamically to most efficiently use all the processors that are available. In addition, the TPL handles the partitioning of the work, the scheduling of threads on the thread pool, cancellation support, state management, and other low-level details. Starting with the .NET Framework 4, the TPL is the preferred way to write multi-threaded and parallel code. Parallelism and concurrency are not the same. Back to the cooking analogy, if the owner of the restaurant decided to hire another junior cook, that is parallelism. Just now I did mention that a junior cook prepare one dish at a time. Let's say all the customer order is a pizza. To deliver one pizza to one customer, the junior cook needs 5 minutes of preparation and 10 minutes of baking the pizza in the oven. After completed for one customer, he will proceed to the next customer. But after a while, the junior cook realized that while waiting for the pizza to be baked in the oven, he can start to prepare for the next pizza. By doing so, the total time spent for the 10 customers reduced significantly. This is concurrency. Data parallelism. The task parallel library supports data parallelism through the system.trading.task.parallel class. This class provides method-based parallel implementations of for and for each loops. You write the loop logic for a parallel.for or parallel.for each loop much as you would write a sequential loop. You do not have to create threads or keyword item. In basic loop, you do not have to take locks. The TPL handles all the low-level work for you. Here I have an example of data parallelism in C#. Let me run this example for you to take a look first. What you see over here is sequential programming. Basically, it will loop for 20 times. Right. If you take a look of the time, the execution time for 20 loops is 10 seconds over here, and for the same task with parallelism, it will take 2.5 seconds. This is an example of how data parallelism help you to reduce the execution time. Now let's examine the code. Over here I have a method. By using stopwatch class, I can calculate the execution time before it starts. We can start to calculate the start time, and after the for loop completed, we will stop the stopwatch so that we can calculate the elapsed time in second. Over here I will loop for 20 times, and in this run job, basically I just create nothing. I just have a thread here to simulate the processing time. This is in millisecond. Let's compare with the data parallelism. Here I'm using parallel.4. Over here we run the n is the total loops which I pass in from the method, the parameter, method parameter. Here I pass in 20. So this is the method parameter which will loop for 20 times. Basically it's the same thing. One is sequential and one is with data parallelism. Let's take a look of another example. Let me run the code first. Over here you can see that a list of fruits. Basically just print a list of fruits together with the thread ID. Over here without data parallelism, you can see the thread ID is always 1, and with data parallelism it uses more than one thread, and the execution time is 3 seconds for data parallelism, while without data parallelism it takes 13.5 seconds. This is the code for the second example, parallel.forEach for collection. Now back to the cooking analogy, and what the customer order is a pizza. To make one pizza to one customer, the junior cook needs 5 minutes of preparation and 10 minutes of baking the pizza in the oven. After completed for one customer, he will proceed to the next customer. This means for 3 pizza, the junior cook needs 45 minutes. Now let's take a look at the code for this. In this code, I will again use the stopwatch to calculate the total time used to make one pizza. Here I have a make pizza method And in this make pizza method, I have prepare pizza method and also bake pizza method. Prepare pizza method basically will just print the console.write line just to print start preparing pizza, and this thread.sleep is to simulate the time used to prepare the pizza, 5000 millisecond, which is equivalent to 5 seconds. And after 5 seconds, you will print finish preparing pizza. Same goes to bake pizza method. Just that for bake pizza method, I increase the sleep time to 10 seconds. Let's run the program. Finish preparing pizza 1, start baking pizza, 10 seconds. Right, as you can see, the elapsed time is 15 seconds just to make one pizza. And if you want to make 10 pizza, one pizza for each customer, we're gonna write a for loop. Just like a for loop for x is equals to 1, x less than equals to total pizza, x plus plus. Here we can change this to, instead of 1 pizza, we can change it to 10 pizza. And let's run the program. Alright, definitely it's gonna take a while to complete this 10 pizza. We're gonna pause this video for a while, and after this complete, we will resume the video back. Right, the elapsed time for 10 pizza is 150 seconds. Previously, I talked about how after some time, the junior cook realized that while waiting for the pizza to be baked, he can start to prepare for the next pizza. And this is known as concurrency. The goal of concurrency is to make our program usable and non-blocking. For sequential, it is blocking. Blocking means while waiting for one task to be completed, another task cannot be started. Non-blocking means while waiting for one task to be completed, another task can be started. Let's take a look of code how we can achieve that. In C#, we're gonna use the async keyword and the await operator to apply concurrency. This is the place that we're gonna put the async keyword, as, y, and c. And instead of returning a void, we're gonna return a task. And instead of using thread.sleep, we're gonna use task.delay. If you mouse over the task.delay, it is under system.trading.task.task. And we're gonna add the await operator here. Now we can command this. This thread.sleep is more on for sequential programming, which is the synchronous. For asynchronous, we're gonna use task.delay instead. Let's run the program to see the output. Started preparing pizza 1. Finish preparing pizza 1. Started baking pizza 1. As you can see, before it finished the baking for pizza 1, it already start to prepare for pizza 2. And over here is finished baking for pizza 1. By the time it finished baking for pizza 1, it's already started to prepare for pizza 3. So this concurrency allows you to run another task while waiting for another task to be completed. So this non-blocking will create the usability to make user feel user-friendly. It is not blocking. And if you take a look of the elapsed time, the total time for 10 pizza is 50 seconds. Compared to the sequential programming, if we didn't really apply the concurrency, it will take 150 seconds if you can remember. Bear in mind that we are still having one junior cook here, which means no parallelism yet. No parallelism means the computer is still using one thread or one processor or one core to do the job. If you copy and paste the code to Visual Studio Community, previously I'm using Visual Studio Code, now I've copied the code to Visual Studio Community. After copy over your code to Visual Studio Community, you can put a breakpoint in this big pizza method and press F5. As you run the program, take note of this thread window. You can open the thread window under debug, Windows, and under Windows there is this thread window. Let's run the program. As you can see over here, there is only one main thread and there will be another one later on. Let's say you continue running the program. Okay. As you can see, there is only one main thread and one worker thread here. No more than that. But we know that in our computer we have more than 2 core. Okay, see, main thread and one worker thread. We haven't really fully utilized our computer multi-core to optimize the performance. Now back to the cooking analogy. The owner of the restaurant sees that, okay, we have one junior cook here and he's doing a pretty good job in concurrency. After that, he decided that, okay, why not I hire another one more junior cook or junior chef to see how another one more junior chef can reduce the waiting time for the customer. Now apply back to our C# code, we can use task parallelism. To be more specific, it is known as task-based asynchronous programming. Right, let's modify our code to apply task-based asynchronous programming. First, I'm gonna replace the method, the prepare method, to async. Instead of returning void, I'm gonna change it to replace, return a task. And instead of using thread.sleep, we're gonna use task.delay. 5 seconds. I'm gonna await for this task.delay. And then we're gonna change the make pizza. Also, the method for make pizza, I'm gonna add async return task await for prepare pizza and bake pizza. And then instead of this for loop, we're gonna To replace this code, var task equals to enumerable dot range 1 to pizza dot select I arrow key. The method is make pizza. Gonna pass in I, and here I'm gonna write task dot when all task. I'm gonna await for this task dot when all, and then this pizza task. We're gonna also add the async return task. Lastly, we're gonna change this pizza task by adding get awaiter get result. Let's run the program to see how it looks like. Control F5. As you can see, when the program starts, straight away it will start preparing pizza for 10 pizza at the same time. This is the difference after we have added the task-based synchronous programming, where we make use our core computer processor, multiple processor, to run all these tasks at the same time. And the elapsed times is 15 seconds. If you remember correctly, before we have made these changes to task-based asynchronous programming, just by concurrency itself, our elapsed time is 50 seconds. After added task-based asynchronous programming, our time now is 15 seconds, 15. Let's try to run the program again by putting a breakpoint. Let's say you can put a breakpoint in Big Pizza, and if you press F5, okay, over here you can notice the difference. Just now we only see one worker thread before applying task-based asynchronous programming. There's only one worker thread, but after applying task-based asynchronous programming, now you can see 4 worker threads. If your computer have 4 core, you will see 4 worker threads here. And this is how you can make use of your multi-core to improve the performance by using this task-based asynchronous program. Let's say one of the customer decided to cancel his order. We can also do that in code. Here I have added this cancellation token source. We can make use of cancellation token source to do that. In my make pizza, I have added the cancellation token source. If the n is equals to 4, I will cancel it, and we can pass the cancellation token source to prepare pizza and bake pizza, and inside prepare pizza and bake pizza, you can write an if statement here. If cancellation token is cancellation request, then you can just throw nil task cancel exception. Let's run the code. Start preparing 10 pizza. When it reaches pizza number 4, it says order for pizza 4 was cancelled by customer. But the remaining pizza, you will still continue to run just that it's, the pizza number 4 is skipped. Over here we can put a try catch to print the error message. Right, hope that you guys learned something from this video. Thanks for watching and I'll see you next time. Have a good day.